Hi, this is Lori and welcome to my series on the Pico W. It's been a while since I've been able to put some content on my channel. I've been traveling over the summer and fall, but I'm back home for the winter and starting to work on projects again. In this two-part series, we're going to be creating an HSV to RGB converter, and that'll allow us to switch between HSV way of coding colors and the RGB way of coding colors, and we'll be able to switch back and forth. Something you often need to do if you want to work with RGB LEDs and neopixels and have some fun. And I decided to put this project together with a Pimoroni Pico Display 2.0. It's a nice little device that'll allow us to display the conversions that we're making, see the colors that we're choosing, and we can dial in various colors we want to look at and be able to see the conversion. Let's get started. This is the Pico Display 2.0 right here. Now Pimoroni makes also a smaller version called the Pico Display. I guess it's the 1.0. But let's first look at the 2.0. We have a nice screen on here. LCD screen, 320 by 240 pixels. The other nice thing about this display is it has 4 buttons that we can use, and we'll use those buttons to dial in various colors we want, switching the HSV part of a code or being able to switch the RGB, dialing through various codes to see what those colors look like and then seeing what the conversions would be. The other nice thing about this display is it has a built-in RGB LED over here. So as we look at various colors displayed on the screen, we'll also be able to see what they look like on an RGB LED. Now the Pico display, the smaller one, you can see it's a 240 by 135 display. It is possible to do this project if you happen to have one of these. Just have a little less real estate on the screen, and I don't think it'll be very hard to change the code to make this project work on either of these two displays. But in the video here, I'm going to use the larger of the two to do the project. Here's the two displays I've been discussing. I have both of them in my lab. It's the smaller one here. This is the Pico display, and you can see the buttons here. We have 4 of them, plus the little RGB LED, and there's our screen. And how it works is you just plug your Pico or Pico W into the back. That's kind of the downside of these, is that once you plug this Pico in, you can't really access any of the pins. So your project has to be kind of complete with just what is on the board here. But it's a nice all-in-one unit, so it's kind of fun. And then here's the larger of the two, the 2.0, and you can see the 4 buttons here, and you can also see the RGB LED here on the side. This is the one I'm going to use for the filming. And yeah, we flip it over, we can see the Pico put in there. We'll talk about the 2 color spaces and how they're defined. So the RGB color space is given by numbers for the red, green, and blue color channels, and we usually give them on a 0 to 255 scale. And sometimes people put it on a 0 to 1 scale for convenience, and we will do that in our conversion functions. It defines a cube with the 3 axes being the red, green, and blue, and we kind of get a cube to display all the different colors that we can make with RGB. And a couple of colors that are important are white, which is all the colors at 255, and then black would be all the colors at 0. I kind of like this cube. I found it's a animated cube, and it shows the different colors. We can see where white is and where black is, and some of the other colors we're probably pretty familiar with. So handy little thing to see and kind of look at. And that's the RGB color space. Next up is the HSV, hue, saturation, and value model. In that model, hue stands for the color on the color wheel, and we indicate which color we're looking at by the angle of the wheel. So you can kind of see a color wheel here, and as you move around at various angles, you'll get the different colors of the color wheel. The other 2 components are saturation and value. Saturation is the intensity of the color. It's usually on a 0 to 1 scale, or sometimes people put it on a 0 to 100% scale. So when we're at the highest values, we're getting the pure, bright color for that particular hue. And as we reduce the saturation, we kind of dull or gray out that color. So that's sort of shown here for a bright pink here. You can see that as we lower the saturation, we sort of gray out the color. Now the other one is value, and it's sometimes also called brightness. And that's the lightness or darkness of the color on a 0 to 1 scale, or again, a 0 to 100% scale. So here's an example of like a teal type color with lowering the value to the point that we kind of turn it almost white. So as we reduce the value, we go more and more to a white color. So those are the other two pieces of the hue, saturation, and value model. If we visualize this particular color model, we get a cone. So we have sort of the color wheel up here, and then we have value coming up and down this way between 0 and 1, and saturation is the sort of the size here, the radius of the color wheel. And as we reduce the value down to 0 and reduce the saturation, we'll get down here to a value that's going to be kind of black. And then if we're up here at a high value, but a 0 for saturation, we'll get a white out of it. So what we need to do is we want to convert between RGB and HSV. And the main reason for that is it's nice to be able to loop around the color wheel. It's easy to put that into a nice for loop and shift around these really pretty colors. And so if you have NeoPixels or RGB LEDs, it's fun to loop through different colors and make some nice displays. But when we go to actually light the LED, for example, we really need to give it an RGB code. So we need to go back and forth sometimes between these two color models. So you might think that there's a library already out there to do HSV to RGB and back. And there is in FullPython, but there's not an official library in MicroPython. There are some out there that you can get from other people, and you think, well, maybe I can code my own. And when you start looking at where the formulas to do that conversion, you find things like this, which are pretty complicated and hard to understand how this gets you from the cube to the cone and the cone back to the cube. And I decided I really wanted to try to understand that. So you can see this is going the other direction. Again, a pretty complicated formula that doesn't make a lot of sense. And again, you can code it and it will work, but you don't really understand how it works. So I was taking Paul McWhorter's Pico W course and catching up, and he had us put together an HSV to RGB function. And as a part of that, I decided to do this deeper dive and make sure I understood how this conversion takes place. So let's try to put this together. Let's first just try to put the hue with RGB codes. And this color wheel is really nice. It shows the color wheel with the degrees and the colors, and it also includes the RGB codes. So this will help us connect the degrees to particular RGB codes. So for red at 0 degrees, the red would be at 255, and the green would be 0, and the blue would be 0. And if we come on around and pick up yellow at 60 degrees, now the red is at 255, but the green is also at 255, and blue is off to make yellow. Keep coming on around, we can see the green at 120. The green channel for RGB is on, and the other two channels, red and blue, are off. And here's cyan at 180 degrees, and the green is on at 255. The blue is on, but the red is at 0. And here's one of these sort of in-between colors, ocean at 210, and you can see that the green is now halfway in between 0 and 255, and the blue is full 255, and the red is off. And you can keep coming on around the wheel, and you can see the various codes and degrees that define the color wheel, and this should help us connect hue to RGB. But we still need some way of coming up with the way to code this so that we can make all the colors that are on this wheel, not just the ones that are marked here, but any particular degree, so that we can turn that into an RGB code. I've taken the color wheel and sort of stretched it out as an axis here, an x-axis, where I go from 0 to 360 degrees. And then here I'm showing the actual pure colors of the color wheel where saturation and value are at 1 or 100%. And so we're not working with those two at the moment. And I've taken the colors from the color wheel we just looked at and put them here with their RGB codes. And then what we're going to try to do is create a graph to help us understand how the red, green, and blue channels are changing as we move around the color wheel. So we'll start first by graphing the red one here at 0 degrees. And the y-axis is going to be the RGB value. So you can think of it as 0 to 255 or 0 to 1 if you want to think of it as normed. So we'll graph the red first. So red is at 255. And the blue and the green are at 0. Now we'll graph the orange color. Well, red is at 255 and green is halfway, 128, and then blue is still 0. And if we go to the yellow, red is at 255, green is at 255, and blue is 0. Now if we draw lines to connect this, we'll see that in this 0 to 60 degrees, red is always on at full 255, blue is off at 0, and green is kind of increasing here, transitioning through the degrees. We're adding more and more green to make the colors as we switch between red and yellow and make that smooth transition. So we're doing that by changing the green value to make that transition. Okay, let's keep going and do another segment. We'll do the spring green. So we'll have the green at full, the red's at halfway, and the blue is off. And then we'll go to the green. Well, the green will be full on, and red and blue are at 0. And again, if we connect this again, we'll see in this window, blue is off, green is on, and the red is transitioning. We're taking red away to go between yellow and green. And if you keep doing this for all the other parts of the wheel here, add that in, we'll get this pattern. And now we can kind of see why one of those formula that we looked at was divided up into those segments, 0 to 60, 60 to 120, because in each 60-degree segment, one color is off, one color is on, and one color is transitioning. And it can either be increasing or decreasing. So with this graph, again, ignoring saturation and value, if I gave you a hue, you could come on here and you could find what the blue, red, and green value were. So that's how we connect hue to RGB. And again, I want to thank Paul McWhorter. He was the one who demonstrated that in his course, and I found this very, very helpful. To bring in saturation and value to our model so that we can convert fully between RGB and HSV, I used the colorizer.org website to visualize this, and I got this idea from Pascal Jobin, who's one of the students in Paul McWhorter's course, and he had a great video using this tool to demonstrate how the HSV and RGB change as we move things around. So we're going to go to that website and try to add in the saturation and value piece to our HSV model. Here we are at colorizer.org, and first we'll just we'll kind of go through and see visually how what we put on our graph works here on the Colorizer app. I have a starting at full-on red, green and blue are off, and you can see here on the hue, saturation, and value part of this converter, you can see we're pointed towards the red, 0 degrees, and saturation and value are both at 100%. Now let's just pull this along, and we'll move along till we get to about the yellow here. So there we are at yellow, and we can see what we found, that red is on, green is on, and blue is off, and that gives us the 60 degrees, and that gets us the pure bright yellow. And as you move around, you'll see things move, and now we can see back up here, there's green, so now we have the green on and the red and blue, and you can see that always one of the colors is off, one of the colors is full on, and another color is either increasing or decreasing as we move through the color wheel. So that's pretty neat. We'll go back to 0 degrees red and start again. So next up we want to figure out how does saturation and value work into this. Now looking at some of those formulas, I had learned that value is the maximum RGB code that we can have. So let's switch our value down to something like maybe 80%. So we'll pull it down to 80. And now you can see that when we're at 0 degrees, but we've changed the value to 80%, now our RGB code is not 255, but 204. So we've reduced it, and that's the max it can be. So it's 80% of the 255 scale. Now that's the max. So value gives us the maximum that we're going to have in our RGB code. Oh, we're getting close to understanding what's happening here. Let's add in saturation. We'll take it down from 100%. Maybe we'll put it at 50% here. And now we can see how the colors have changed. So now we're at 0 degrees. So this is our red on the color wheel. But now the red, it reads the 204 because of our value being at 80%. But also notice now green and blue are on to, they're not 0 anymore. So it's brought them up, and you can see that this is what we have. Now if we slide through the color wheel, let's watch what happens to our colors. We're still seeing that sliding back and forth. One is off, one is on, and I'll just go back the other way. You can see them bouncing around. So the saturation actually helps define what is the range of the RGBs that we're going to be using, what is this part of the bar that we're going to be using, and also how low our colors will be able to go. And we'll take a look at how those formulas come about. And now we can take the graph that we created with value and saturation at 100% and revise it to show that when we reduce those below 1, then we're going to narrow the range that we can use for the RGB code. We saw on the colorizer.org that the value gave the max code if we put the RGB codes on a 0 to 1 scale. So now you can see why it's useful to norm the RGB codes to 0 to 1 rather than have them go from 0 to 255. So then value would give us the max RGB code that we'll have. And it turns out that value times 1 minus s gives us that minimum. Rather than it being 0, it'll now be this particular equation. And it turns out that value times saturation gives us this range of the bar. When you noticed when we were looking on colorizer.org, it was bouncing around, but only in between two values inside of the full range of the RGB code. Well, that's great. So now we can kind of divide up the color wheel into these sections, and I specifically named them section 0 up to section 5. And it's pretty easy now to see that if we have a particular hue, say somewhere in the 0 to 60 degree range, then we'll be able to figure out what, for example, the blue is. We know the blue's the minimum, and we know the red should be the max, so we have the equations for that. And now all we need to do is figure out where are we on this line for the green so that we can get our green code. And we'll need the slope of this line to make that calculation. The slope is the change in y over the change in x. And if we go from 0 to 60 degrees, we know we're going to shift this much in the y. We're going to shift the value times the saturation. And that is our slope of this green line. And if it's going the other way, in this section for the red line, we'll just make that the negative. That's the slope of that line. So now we have all the pieces we need to do this calculation. So if our hue is here inside this particular section, what we need to know is this change in y so we can find this point on the green line. We know the change in x because we know what the hue is, so that'll tell us how many degrees we are from 0. And we know the slope of this line, so now we can figure out this distance here. And so we're just taking our slope formula and flipping it around so we can find the change in y. And so the change in x times the slope will give us this particular distance. And then we'll just add on the minimum value so that we get this particular point on the green line. Now to go the other way, RGB to HSV, we'll use which of the red, green, and blue values are the largest and the smallest to figure out which of the sections we're in. And so we know that value is the max of those. And then the min, if we turn this equation around, we can solve for saturation, and that'll give us that. Now all we need to do is figure out which hue we're on. And to do that, we're now just going to kind of flip around our thinking that we used to go the other direction to go this direction. So now we're interested in finding the hues, so the change in x. Where are we on this degree scale? So we know what section we're in, we just don't know which, how far we're into each section, but we'll use the change in y to figure out what change in x we have. So we'll flip our slope formula around and we'll solve for that. So we'll know the change in y and we'll know the slope so we can figure out the change in x. A couple little things we'll have to pick up along the way. If the value is 0, then the saturation is 0, and the color is just going to be black, so we'll set the hue to 0. And if the max and min RGB are the same, then now the color is on a white to black scale, and the hue is set to 0 degrees. And the saturation would also be 0, and the value determines what amount of gray we have. A value of 1 is full white, and a value of 0 would be all black. So we'll have to catch that in our code. Now we're ready to take a look at our MicroPython code finally to create our two functions. Now it's time to take a look at our code. We'll make those two functions to go in either direction. We'll start off with hue, saturation, and value into RGB. We'll provide those three values, and I'm expecting the hue to be on a 0 to 360 scale, saturation and value to be on a 0 to 1 scale. I'm not doing a ton of error checking here, and I want to also say that this is not the most efficient way to do this conversion. This is a way to do the conversion that it shows understanding of what's happening. So definitely other kinds of conversion routines that will be more efficient than mine. Again, mine is to demonstrate that we kind of understand how we go back and forth. All right, so we'll, if somebody does put in 360 for the hue, we'll go ahead and do modulo 360, so we turn it back into a 0 degree. And that's just in case we do some looping through 0 to 360 and we end up at 360, we'll go back to 0. Then we're going to figure out which of those sections we're in. Are we in 0 to 60, 60 to 120, and so forth. So we'll make a variable called section. We'll divide the hue value by 60 and take the integer for that, and that'll get us a 0 through 5 answer. Then we'll do some of those basic calculations. We know that the max RGB, and it'll be normalized, is the value, and the min RGB will be the equation that we showed, value times 1 minus the saturation. And then we'll get that range, value times saturation, and that gives us the slope that we went through and calculated. Now we'll go through each section and figure out the R, G, and B value. And once we know which section we're in, we'll automatically know which is the max and min. So for example, in section 0, we know that R is max and B is min, and G is the color in transition. So R is max RGB, B is min RGB, and then here's where we'll do that calculation using our slope, where we find how far we are over from the 0 degrees, calculate that distance, multiply it by the slope. That gets us the change in y, and then we add in the min RGB, because that's sort of the baseline that you saw on the graph. So if we add all that together, that should give us the correct normalized value for G. The other sections are the same, concept. So if we go into section 1, for example, now we know that R is the value that's changing, it's decreasing in this section. G is the max and B is the min. So there we go, G max, B min, and here's the R calculation. Now this time we're going to calculate how far we are from the beginning edge of this section, 60 degrees. We'll subtract the hue, subtract 60 off of the hue, multiply that by the slope that gets us the change, and then we'll subtract that off the max RGB, so I get the drop that we'll have for the R normed value. Then the rest of the sections are all similar, depending on whether it's an increasing change for that one color or a decreasing change for the color. Same concept, but we change where our starting window is, and we get all through the 5 sections. Then we want to put our RGB values back on our 0 to 255 scale, so we'll multiply them by 255. I took the integer just to give a 0 through 255 value, and we'll return that out of our function. Here's our code to go from RGB to HSV. So we'll provide the R, G, and B codes, and I'll expect them to be on a 0 to 255 scale. I'll normalize them to make it easier to do this math. Then we'll get the value in saturation because we know that those are dependent on the max and min RGB only. So first we'll get the max RGB and we'll set that to the value. And then we'll get the minimum RGB, and now we'll calculate the saturation. But we need to check if value is equal to 0, then we want the saturation to be 0. Otherwise, we want to do the calculation with the min RGB in it. So that'll get us both value and saturation. So we're pretty far along already. Next, we want to just check if the max and the min are equal. Then that does mean we're on the white to black scale, and we're just going to have grays in between. So if they're equal to each other, we'll set the hue equal to 0, and we'll immediately return everything because we have all we need. We have the hue and the saturation value, which we calculated above. Otherwise, we're going to go figure out which section of the color wheel we're in, which 0 to 60, 60 to 120, 120 to 180. And that we'll figure out based on which is the max color and which is the min color. And if we know those two, we'll go in and do some calculations. So the first thing we'll do is get the change in Y. So we'll take the G value, because that's the one that's changing in the first section, or section 0, I should say. And we'll subtract off the min RGB. Then we'll calculate the change in X using the equations that we developed before. And then the hue will be the delta X plus the beginning of that, beginning degrees of that section, which happens to be 0. The same logic applies again to all the other sections. But this time we have a negative slope in section 1, for example, in the 60 to 120. So again, we'll calculate the delta Y. So the R is the one that's changing because G should be max and B should be min. So R is the color that's changing and it's decreasing over this window. So we'll take the R norm and we'll subtract the minimum RGB from that. We'll use that to calculate the change in X. And this time we'll calculate the hue by subtracting it from the end of that window, take off the delta X, and that'll tell us where the hue is. And then we'll stop the function by returning at that point, returning all the values. And we keep doing that for each of the sections of the color wheel till we get to the end. And we should have fallen in one of those, and we'll be able to have a returned hue, saturation, and value from each of those sections. Well, that's the code I put together. Again, not the most efficient, but the idea was to make sure we understood how the conversion was actually occurring. Now it's time to just test them out. And here's some code that we can use to test out our functions. We'll put those functions in a separate file. I have them here on my Pico, and we'll import that so we can access them. And then in our while true loop, we'll ask the user through the shell whether they want to enter an HSV value or an RGB values and get the conversion. So if they say HSV, we'll ask them to enter the hue, saturation, and value. We'll do the conversion, and we'll print the results back out. both the input values and the RGB values that we calculated with our function. And then if we say RGB, then we'll ask them to enter the RGB values. We'll do the correct conversion to go to HSV, and we'll print those results to the screen. We'll put the input values in, and then the hue saturation values that we calculated. And have just a little bit of checking in here, just if somebody doesn't type HSV or RGB, it'll keep going around asking them. And if we do a keyboard interrupt, we'll stop the program. All right, so let's give this a run. Well, let's start off with HSV. So we'll say HSV. And let's enter something we know. So 120 degrees should be green. And if I put a saturation of 1 and a value of 1, I should get the bright green, right? So I should get, yeah, all green, 255, and red and blue should be 0. All right, let's try another one. How about magenta? That's a 300, oops, got to type in HSV again. And that's a 300, right? And let's go ahead and ask for the pure color again. So ones, and yeah, we can see magenta is a combination of the red and the blue, and the green should be 0. So that seems to work. Then let's try the RGB. We'll type that in, and we'll enter our red value. Maybe we'll do a full red, so 255. And green we'll set to 0, and we'll set blue to 0. And we should get back a hue of 0 degrees and the saturation and value set to 1. Let's try another one. Let's input something in between. So we're going to get something other than 1s for saturation and value. So maybe 128 for the red and 255 for the green. And we'll turn the blue channel off. And whoops, I didn't get, yeah, I put in something that would give us a pure color. And so saturation and value, and here's our hue, so almost exactly 90 degrees. We try again. And we'll pick some values in between. So 128, 255, and 30 for blue. And there we go. Now we can see we have a hue at 93, and saturation is 0.9, and the value is equal to 1. So I've tested it quite a bit, and I actually did a whole bunch of error checking to make sure it was working right by using the colorizer.org website to make sure I was getting all the correct values under as many scenarios as I could think of. So I think it's working correctly, but please share with me in the comments if you see any error in the code, and I'll put a link to my GitHub site so that you can see the code that I have put together. And I hope you'll join me for the next episode, because it's a little less teaching and less coding, and we'll get to actually using that Pico display and having some fun with the colors and actually seeing the results of all this good hard work we put in. Thanks for watching.